So we're going to be recapping a freefall problem. The problem says a rock is falling from the roof and takes 5 seconds until it reaches the ground. If another rock was thrown 1 second after the first rock, how hard do you have to throw it in order for it to reach the ground at the same time as the first rock? Also, how high is the roof? So, before we start solving, we have to make our model, and our model is shown here. So, this is going to be the roof, and we're trying to look for the displacement. So, we have to find out how high the roof is. And these are going to be the two rocks that are going to be in free fall. This rock would be the first rock, and this one would be the second one. I put the first rock a little bit lower because this is the rock that's not going to be going at a faster speed. And this rock is going to be at a faster speed since it's going to be thrown 1 second after the first rock. So I set it up like this. So we're going to be filling in what we already know. So for the initial velocity, we already know that it's going to be 0 meters per second. And we also know that the acceleration is negative 9.8 meters per second squared, because the negative 9.8 meters per second squared, whenever it's in free fall, that's always going to be the number. And we also know the time, and the time would be 5 seconds. It would be 5 seconds because the rock is falling from the roof, and it's going to be taking 5 seconds until it reaches the ground. So that's what we know so far for rock 1. What we know for rock 2, obviously the initial velocity would be 0 meters per second, just the same as rock 1. We also know the acceleration, which is the same, negative 9.8 meters per second squared. Okay, just fit it. We also know the time. The time is going to be a little bit different. Rock 1, the time was 5 seconds, but rock 2, it's actually going to be 6 seconds. It's going to be 6 seconds because it takes 5 seconds until it reaches the ground, and when the second rock is being thrown 1 second after the first rock, it's obviously going to be at a faster rate, a faster speed than the first rock. So we would add 1 to the 5 seconds because it's going faster, and it's going faster by 1 second since it's being thrown at 1 second after the first rock. Okay, since we know so far what we have, we're going to be going down to the equations. And as you can see, this is the work for rock 1, this is the work for rock 2. So for rock 1, we're trying to look for the displacement. And we're trying to look for that because we have to answer the question, which is, how high is the roof? And for us to first answer that question, we have to look for the displacement in rock 1. So here is the equation that we use for displacement. And I used unit analysis and got my answer, which turned out to be negative 122.5 meters. So obviously, if we're answering the question, how high is the roof, obviously it wouldn't be a negative, so it would just be changed to a positive. So we can write that in for something we now know, which is the displacement being 122.5 meters. So now we're going to look for our final velocity. And our final velocity equation is right here. And here's the work for it. And after I did the work, I got an answer of 49 meters per second. So for final velocity, we can put that in now as 49 meters per second. So now we have everything we need to know for rock 1. Now moving down to rock 2, here's the work. So I just put, just in case you were confused, I just put the time and why it's different and not 5 seconds. And instead it's actually 6 because we used 5 seconds since it takes 5 seconds to reach the ground. And we're adding another 1 second to it because of, again, the second rock being thrown 1 second after the first rock, in which it will increase the velocity. So here's my final velocity equation once again, and I also used unit analysis to get my final answer of 58.8 meters per second. So we could plug that in. So it'd be 58.8 meters per second. Okay, so we have rock 1 and rock 2. The reason why we don't need to find displacement for rock 2 is because we already have displacement for rock 1, and we already know that we answered one of the questions, and which was how high is the roof. So we're just going to take rock 1 and say it's 122.5 meters. That's how high the roof is. So we can just put here, not needed. So we have everything we need for both, and we already answered the question. So the two questions again were, if another rock was thrown 1 second after the first rock, how hard do you have to throw it in order for it to reach the ground at the same time as the first rock? So let's answer that one first. And we already said that after 1 second being thrown after the first rock, our answer would be under rock 2, the final velocity, which is 58.8 meters per second. And to answer the second question, again, also, how high is the roof? The roof would be 122.5 meters. So that is just one example of free fall.